Hello, my name is Mike, and welcome to my build video for the Befaco Percall Eurorack module. In this video, I am documenting my experience building a Percall, and while it is not necessarily intended as a how-to video, I do hope you find this video useful. This is not a sponsored video. I bought this kit with my own money, so I am free to share my honest reactions to the module and the kit. Here I'm showing the first page of the instructions. The instructions say color code can be difficult to identify. We strongly recommend to use a multimeter, and I agree 100%. I gave up on using color codes pretty early on, and in most cases just prefer to use a multimeter. I like to use the instruction sheet as a checklist as I place and solder the various components. Here, I'm opening up bag A, which includes resistors, diodes, and ferrite beads. I put the ferrite beads and diodes back in the bag as I know the resistors will keep me busy for a while. My preferred method is to measure the resistance for every group of resistors and write them on the paper tab that holds them together. This build took about 6 hours, and about half of that time was spent on just the resistors. So I like to take inventory and make sure I have all of them before I even start soldering anything. Sometimes, if a kit is missing components, you can still get the resistors done while you're waiting for the missing components to arrive. But if you are missing resistors, it's probably better just to set everything aside until you have everything ready to go. As I measure each group of resistors, I put a circle next to their value on my instruction sheet so I know it's accounted for. Then, after I solder all of the resistors of that value, I can check off the circle to show that I am done with that group of resistors. I do want to mention that the background music you are hearing was made using this completed Percall module. The final 5 resistors are each one-off values, so as I measure each one of these, I place them in their spots on the board. I like to solder the smallest group of resistors first, and then move on to the next largest group of resistors. I think this helps cut down on the chances of misplacing a resistor, and makes it easier when placing the value with the most resistors. If every other resistor is properly placed, then placing the final 31 resistors is just a matter of finding the remaining open places for resistors on the board. As I solder each resistor, I make sure to check it off on my instruction sheet. And once all of the resistors of a certain value are soldered, I check off the circle I drew when taking inventory at the beginning. Here, I'm showing how close together some of the resistors are. R2 and R3 both seem to be touching one leg of transistor 2. R12 and R13 both seem to be touching one leg of transistor 3, and R15 and R16 both seem to be touching one leg of transistor 4. I decided that part of the main PCB was getting crowded with the 2K2 resistors, so I skipped to the last 4 on the control PCB. After these resistors are soldered and clipped, I'll go back and add the middle 4 2K2 resistors. There are some through holes here that are so close together that it's hard to tell whether they're connected or not. Here I'm using gravity to try to get the solder to flow away from the hole next to it. Afterwards, I looked up the schematic on Befaco's website, and it does appear that these two resistors are connected, so I decided not to stress out too much over whether or not they were bridged. Now we're done with the resistors and I check off the last batch. We move on to diodes. I start with the two larger ones. It is important that the line on the diode matches the line on the PCB. With diodes, I solder one leg on the first diode and then one leg on the next diode before going back and doing the second leg on the first one. This is because diodes can be overheated, and this gives the diode a few extra seconds to cool down. Now I'm moving on to the 11 smaller glass diodes. Once again, I am soldering one leg of every diode and then going back and soldering the other leg. This way there's a lower chance of any of the diodes being overheated. There were 4 diodes all in a row right here, so I decided to place 3 of them, solder and clip their legs, and then go back and do the 4th one. This way I'm not overcrowding the board all at once. The last parts in Bag A are the Ferrite beads. These are little plastic cylinders that you put discarded resistor legs through and solder to the board. They create a filter so that high-frequency noise from the electrical power portion of the module doesn't bleed through or interfere with the module's audio signals. Next up are the IC sockets. IC sockets make it so you don't have to solder IC chips directly to the PCBs. By soldering IC sockets to the board, you can plug and unplug the IC, which is a good thing, as I will demonstrate later. One must take care to make sure the IC sockets are oriented correctly. There's a small notch on one end of each socket that must match with the notch printed on the PCB. When soldering sockets, you want to try to get the socket as flat as possible against the board. Solder one pin and check to make sure the socket is still lying flat. If it's not, you want to reflow the one pin you soldered and push down on the socket to make it flat. Once one pin is soldered and the socket is flat, I like to solder the pin in the opposite corner from the first one, and then double check to make sure the socket is still lying flat. Then I will solder the rest of the pins. Now we're moving on to Bag B, which are capacitors and transistors. The Percall includes non-polarized ceramic capacitors, non-polarized film capacitors, and polarized electrolytic capacitors. First, we're going to sort the non-polarized capacitors and make sure we have all of them. Everything I needed was included in the kit, but just in case, I do have a box of assorted ceramic capacitors that I got off Amazon for less than $10. Each ceramic capacitor is worth less than a penny, so it's good to have extras on hand in case you're accidentally shorted in a kit, which has happened to me before. I noticed the four 100 picofarad capacitors on the right were different sizes. That happens with capacitors from time to time. As it turns out, the one big one fit the Percall board better than the three smaller ones did. But they're all perfectly usable. For some reason, it was actually really easy to see the solder travel up the legs of the film capacitors. I'm sure it didn't show up on camera, but it gave a sense of reassurance that the solder was flowing well. I got no such feedback from the ceramic capacitors, so I have to assume the legs on the film capacitors are made of a different material. Right here, there are 8 2N2 film capacitors all right next to each other. I decided to do the first and third grouping first, and then go back and do the second and fourth grouping, so I have plenty of room when soldering and clipping their legs. Here, I'm just showing my list of crossed off capacitors. Next up are polarized electrolytic capacitors. These have a longer leg and a shorter leg. The longer leg is positive and must go through the hole with a plus sign on it. As you can see, I had a hard time getting the cardboard off the legs of the capacitors. For some reason, it seemed extra sticky. I always worry about pulling too hard on these and accidentally pulling the leg out of the capacitor itself, but so far that has never happened. Like diodes, electrolytic capacitors can also be overheated, so I solder one leg for each capacitor at a time before going back and doing the second leg for each of them. Next up, we have the three-legged transistors. I have never done a module with so many transistors on it before. First, I count to make sure I have all 13 of the 3906s, and then I start placing the 6 3904s. Transistors can also be overheated, so when I solder them, I do one leg on each transistor at a time, then go back and do the second leg, and then finally go back and do the third leg on each. This way each transistor has a little time to cool down between soldering. Now we're opening up bag C. First we'll do the pin headers and sockets. The instructions say to make sure they are lying flat when you solder them so they line up correctly when you connect the two boards. But I prefer to connect them and then solder them to make sure that everything lines up. Therefore, I need to break apart the boards. Here you can see I'm soldering one pin of each socket to secure them. Then I go back and do the opposite corner of each one. Then I flip everything over and do the same for the pin headers before soldering all of the pins. Now I pull apart the boards again, because I still have components to add on each side. Next I will add the power connector. Now I like to pull out the power cable that comes with the module to make extra sure that I'm orienting the power connector the right way. Now that everything's been soldered on the main PCB, I'm going to go ahead and place the ICs. Normally I like to wait until the last possible minute before placing ICs, but since all but one are on this PCB and this PCB is pretty much done, I decided to go for it. Each of the 8-legged TL702s has a circle on it that tells you to orient the chip so that the circle on the chip is on the same end as the notch on the socket. I realized while mounting the TL704s that the 14-legged chips each have a notch on one end and a circle on the opposite end. The notch should go on the same side as the notch in the socket. I put one of the AS3360 chips in so that the circle was at the end where the notch should be. I didn't realize there was both a circle and a notch, I only noticed the circle. Luckily, I didn't solder this 14-legged chip onto the board, so all I need to do is pull the chip out of the socket and turn it around. I did have a hard time pulling the chip out due to its proximity to a capacitor on each end. I tried using a multimeter probe, a discarded piece of the PCB, and finally a tweezer to pry it out. The most important thing was not to stab a hole into the chip, as it would be ruined. So the 8-pin chips have a dot to denote how you're supposed to line them up with the notch on the IC socket. But then the 14-pin ones have the dot on the back, and this notch that lines up with the notch in the IC socket. This one has the circle in the back and the notch in the front, even though they're both the same type of chip. They're both AS3360s. This one has the notch in the front, no circle in the back. Their print is slightly different, but the logo is for the same manufacturer. Now I'm going to install the spacer. I use pliers to tighten the nut to the spacer, making extra sure that I don't touch the board with the pliers so that I don't accidentally scratch it. Next, I'm adding the faders. I'm noticing that the middle two faders don't sit flat like the outside ones do. It appears the pins of the IC socket on the other side of the board are preventing the faders from lying flat. After the mishap with my noise Plethora build, I'm not exactly excited to trim down the pins. Now I'm going to reflow each leg of the IC socket just to be safe. I figure it's better to do this now whether I need it or not, rather than finding out I need to do it after the faders are already soldered in place. As I place the faders again, I find that the second and third fader do feel much better, so I think the effort was worth it. I need to solder the faders in place, but of course it's difficult because the faders will prevent me from laying the PCB flat. I solder one pin at a time, then make sure the fader is flat against the board, and then I solder the bottom pins before soldering the rest. Next up, I'm placing the potentiometers, switches, jacks, and LEDs. We're not going to solder them until the front panel is secured, we're just placing them for now. Each pair of jacks on the bottom has a pin that shares one hole. Sometimes it's a bit wonky fitting two pins into the same hole. Now I'm placing the front panel. I had a hard time with this one. Something about the jacks needed a lot of finessing before the panel would sit properly. Once I finally got the panel down, I secured it by putting a nut on the four corner jacks. I want to solder the LEDs first so I can trim away their legs to get them out of the way. I check multiple times to make sure each LED is in its hole on the front panel. I solder one leg, then check it again to make sure it's still sitting properly before soldering the second leg. Then I check it one more time before moving on to the next LED. I had an idea to try testing the Percall before soldering in the pots, jacks, and switches, but it became immediately obvious that wouldn't work as the jacks were able to pop out of the PCB. I decided not to do that and instead secured the rest of the nuts onto the pots and jacks so I could solder everything before testing. Now I'm soldering the switches into place, then I'll move on to the jacks, and finally the potentiometers. But I've decided I'm not going to solder the location lugs of the potentiometers until after I've tested the module. The location lugs are the two large legs on each pot, and they are there to secure the potentiometer. After what happened with my noise plethora module, I posted a thread on Modular asking if soldering the location lugs was really necessary, and was told that yes, they are, because without them, regular use could eventually damage the pot. They prevent you from twisting the pots until the 3 pins that process signal bend and break off. As I said, I'm leaving the location lugs for after I test the module, because in my experience, they are pretty much impossible to desolder. Now we connect the boards so we can test. Nothing happens when I power the module on, but that's just because none of the lights or anything come on when it's powered. The 4 LEDs only light up when they receive a trigger. Feel pretty good about that. With the test successful, now I must separate the boards so I can solder those location lugs in place. One thing I forgot to do before testing the module was to run a continuity check on the power pins with the multimeter. This should always be done before plugging a module into a power supply, otherwise you might have a short and not know it. I got lucky and the module is working fine. Here I'm showing off my nearly empty spool of solder. This was my first 8-ounce spool of solder bought from Radio Shack years and years ago when Radio Shack was a place you could go and actually buy electronics stuff. I have a new 16-ounce spool ready to go, so I was in no danger of running out of solder for this build. Now I'm putting on the knobs and the rubber covers for the faders and making sure everything is tight before placing my Percall in my case and making some tunes with it. Thank you so much for watching my video on building a Befaco Percall. If you watched all the way to the end, please consider liking and subscribing. Have a great day.